Okay, good morning, dear students and my friends. Today we will learn about the limit of the function. Basically, the limit of the function is the approaching value of a function. Let us take a function y equal to fx. This is a function y equal to fx, in which x is an independent variable and y is dependent variable. Okay, when and let us take in a point in x-axis. This is the x-axis, this is y-axis, or this axis is also known as y equal to fx. Suppose that when we approach the independent variable x to a, and suppose the value of y approach to L. Suppose that the value of y approach to L. This is the L in y-axis, approach to L. Then the limit of the function y equal to fx is known as L. Or we can say that this is the line x equal to a. This is the line x equal to a, and this is the line x equal to a. In this case, when we approach x to a, it's mean the limiting value is mod of x minus a is very small, less than delta. Delta is a small number. Okay, this is very small. इट्स मीन जब हम इस पॉइंट्स की तरफ जाएंगे तो हमारे पास क्या होगा, ये वैल्यू बहुत ही छोटी होनी चाहिए. हम इस पॉइंट के नजदीक जाने चाहिए, और इस पॉइंट के नजदीक जाते इस समय अगर इस फंक्शन की वैल्यू एल की तरफ जा रही है, देन द लिमिट ऑफ द फंक्शन इज एल. फॉर एग्जाम्पल, लेट अस टेक एन एग्जाम्पल. y इक्वल टू 1 अपॉन fx इक्वल टू yx इक्वल टू 1 अपॉन x, और y इक्वल टू 1 अपॉन x. When x tends to infinity. Okay, graphically the graph of 1 upon x is this. The graph of 1 upon x is this is the graph of 1 upon x. This is the graph of 1 upon x. Okay, this point is 0, this is infinity, this point is infinity, and this is minus infinity, and this is minus infinity in x-axis. Okay, this is the graph of 1 upon x, or graph of 1 upon x is also this, the graph of 1 upon x. Okay, in this case, when x tends to infinity, the independent variable tends to infinity, the graph tends to 0. ये ग्राफ 0 की तरफ टच हो रहा है, मतलब इस लाइन को टच कर रहा है. The graph tends to 0. It's mean the limit of this function is 0. Or mathematically we can solve it when x equal to let us put x equal to 0, x equal to 10, x equal to 100, x equal to 1000. Suppose that x equal to 1, then the value of y equal to 1 upon 1 equal to 1, and second value is x equal to 2, then the value of y equal to 1 upon 2 equal to 0.5. Similarly, x equal to 10, then the value of y equal to 1 upon 10 equal to 0.1. X equal to 100, y equal to 1 upon 100, and it is equal to 0.01. Similarly, x equal to, suppose that 1 lakh, this is 1 lakh, then y equal to 1 upon 1 lakh, and it is equal to 0.00001. Similarly, x equal to suppose that x equal to 10 to the power 7, then y equal to 0.0000001. It's mean when we approach x to infinity, x को हम infinity की तरफ approach करें, then the value of y approach to 0. It's mean 0.001 is 0, tends to 0, this is tends to 0. It's mean when we approach x to infinity, then the value of y approach to 0. It's mean the limit of this function is 0. That is, we can write it limit x tends to infinity 1 upon x equal to 0. Okay, we can take another example. of the limit. Another example of limit is y equal to x square. Okay, for this example, uh, the graph of this example is, this is the graph of x square. This is the graph of x square. This is positive side infinity tends to infinity, and this is negative side. This is positive infinity and negative. When x tends to infinity, in this case, when x tends to infinity, it's mean when x tends to infinity, the graph tends to infinity. This is tends to infinity. When we put x equal to 2, then we have 4. X equal to 10, then we have 100. X equal to 100, then we have 10,000. Similarly, when we put x equal to when it's mean x tends to infinity, x, the independent variable, tends to infinity, the graph tends to infinity. So the limit of this function, in this case, x tends to infinity, x square equal to infinity. This is the second example of infinity. It means limit is the approaching value of the dependent variable with respect to the independent variable. When independent variable approach to a, then the dependent variable approach to L, and L is known as the limit point of the function. Okay, or we can say that limit is a approaching value but not a fixed value. For example, let us take a constant function. Suppose that y equal to 2 is a constant function. Okay, this is a constant function, y equal to 2. The graph of the y equal to 2 is 1 and 2. The graph of y equal to 2 is this. For every value of independent variable, this is the independent variable, this is the dependent variable. For every value of x, we have only one value of y equal to 2. It means this is a constant function. Let us take a independent variable 5. Suppose that 5 in x-axis. This is x-axis and y-axis 5. For independent variable 5, we have the value of y equal to 2. For independent variable 10, we have the value of y equal to 2. It means if we approach any independent value, if we approach x to 5, then in the neighborhood of the 5, we have all the value of y is 2. Similarly, if we approach from left hand side to 5, then in the neighborhood of 5, all the value of y is 2. Clear? It's mean the limit of this function y equal to 2 is also 2, and the value of the function y equal to 2 is also 2. In this case, the function is a constant function. This is the basic logic of the limit of the function. Okay. In our next lecture, we will learn about the left hand and right hand limit of the function, and we will solve the left hand and right hand limit of a function. Thank you.